Good afternoon. I'm Jeff Layton. I'm from Amazon Web Services, and I'm an HPC architect. I'm going to talk about cloud data management. So I'm going to talk about cloud data management, also a little bit about cloud movement. But a lot of times people, when they think of cloud, they immediately say cloud is one thing. There's one set of storage for cloud, and that's not actually the case. There's a multitude of possibilities, and so what we like to tell people is that there's not one cloud storage tool. It's just a number of tools. So there is no one tool to rule them all, with a kind of riff there. But our opinion is to use the right tool at the right time. What I'm going to talk about today are the various tools, and I'm going to talk about what some of the times are you might want to think about in terms of using data in the cloud. So this is just kind of an overview of all the possible storage solutions we have. I'm going to focus on the two boxes on the left. These are mostly more about SQL storage or data warehouse or something like that. Although this one's kind of interesting, Amazon Kinesis, because it's about streaming data. So you can bring IoT devices and you can bring the data into the cloud. And I'm not going to talk about EFS. That was announced about a year ago. It's our NFS as a service, Elastic File System. I'm not going to talk about that, but I'm going to talk about the other options. So the right tool at the right time. So let's talk about the right time. I think of it just kind of a standard workflow as different phases of data. When you need the data, where you need it, and what kind of conditions should the data be stored under. So I think of it as you have an input data set, you have data while you're running, then you have an output data set, and you want to store that data for analysis, maybe long term, and then archive that data. You want to keep it around for a little bit longer, or you may have regulations that require you to do that. So in input data, I think you want to put it in durable storage, because you don't want to have to reproduce the input file. You want to make sure that you can match the input file to the output file, so you want to make sure both are there. So you want what we call durable storage. The data is not going to disappear. Data while running, you want to make sure that all the nodes, all the instances computing have or access to the data. So you want like a shared file system, Lustre, NFS, something of that nature. So maybe not as durable, but definitely shared. The output data, you want to make sure it's also available to the compute resources because they may be doing MPIO or some sort of data sharing. And then when you want to store the data after it's done running, for analysis, you want to put it back on durable storage. You spent all this time running, and you want to make sure that your data's there when you're done. So you want to put it on durable storage. And then after you're done analyzing it, but you want to keep it around, you want to archive it. And it has to be durable as well, but hopefully very easy to use. You don't want to have to fill out forms or any kind of interactive GUI just to store your data. You just like to actually be able to move it automatically. So I'm going to talk about you see two kind of dominant sets of storage, durable and access to compute resources, meaning shared storage. So I'm going to talk about those two, and then I'm also going to talk about how to get to archive. But above all, this I always put it last, but this is my personal pet peeve, I guess you would say, is no matter what you're doing with your data, you always have to be able to manage and monitor it. Where is your data? Who owns it? How much data do you have? Who has access to the data? What are the permissions on it? How old is it? Can we maybe archive it or can we erase it? So all of these mundane jobs that you might think you don't want to mess with are actually very, very critical to your data. So the three main storage types that I'm going to talk about, the first one on the left is block storage, which is NFS or CIFS storage. Can be used for that, and we have a product called the Amazon Elastic Block Storage, EBS. And then in the middle of the durable storage, we have Amazon S3, and it's object-based. And then we have Amazon Glacier, which is for archive, and that's also object-based. So these are the three predominant data solutions we see people use in the cloud for HPC or technical computing. But trying to choose between which one and which one fits into your needs, I always like to say these are the four questions that you need to think about. What are my durability needs? What are my scale needs? What are my application needs? Do I need a lot of I/O or a little I/O? And how much are my costs? So when I walk through these three things, keep those in mind, make sure I cover each one of those. The first one I'm going to cover is Amazon S3, Simple Storage Service. This is very durable storage, scales to basically infinity, but you store the objects, you store files like objects, so you can't access individual portions of the file. You actually either get the whole file or you get nothing. It's typically write once and read many, so you're not going to use it for running applications. It's a bit slower than what you might think of that applications need. So since it's basically infinite, for all intents and purposes, we break the storage up into logical parts, and we just call it a bucket. And in each bucket, you can store objects as many as you want. You can go thousands, hundreds of thousands, millions in a bucket. And the buckets also allow you to divide your data into groups and share that a lot easier than just having all the data together. And the buckets are all within one AWS region, and this is something I really want to point out. At Amazon, we have what we call a shared security model. So from the hypervisor down, Amazon owns the security. From the OS up, the customer owns the security, and they also own the data governance. Where do you put the data? So if you put the data, for example, in Virginia, it stays in Virginia. It does not move anywhere else in the world. The only person that moves the data is you, the customer. We have no way of moving it for you. But some people like to talk about the idea of replication, mostly for disaster recovery, so they want to move that data to another region so that they have it for backup. Before you had to do that manually, but now we have a process that's fairly new that you can do replication across regions really easily, one command. But remember, this storage is all about durability. So S3 has 11 nines of durability, and you can see 2 nines to the left. That's not a minus, by the way. It's 2 nines to the left and 9 nines to the right. So I'm not going to compute the numbers. I'll leave that up as an exercise for you to figure out, how much data you're going to lose in a year. And it's extraordinarily, you're not going to lose any. I've never met anyone who's lost data. It's actually also pretty inexpensive. So if you want the full durability and availability of S3, it costs about 3 cents per gigabyte per month. It does vary from region to region around the world, but this is kind of just a starting point, a rule of thumb. But this has got full durability, 11 nines. We have another implementation of S3 called Standard Infrequent Access, SIA, where it still has the same durability, you just don't access the data as often, and that's a lot cheaper at 1.25 cents per gigabyte per month. So if you need the durability but you don't access the data very often, this is great. But if you access it reasonably often, you can just use the full availability and durability. And then our second durable storage product I'm going to talk about is Amazon Glacier. And Glacier and S3 actually can be combined. I'll talk about that in a minute. Glacier is intended as archive storage. This is where you take your data that you're not going to access for a long time, and you move it there and leave it. If you use tape, some people call tape cold storage. This is kind of the same concept. It can be integrated with S3, so you can develop policies that say, for example, I have data in S3 that's been there 6 months. I haven't touched it, so I'm going to move it into Glacier. Or vice versa. If I have something in Glacier and I want to check it every 3 months, you can move it back to S3. You can also create policies based on user, the size of the file. If the file's over a terabyte, immediately put it into Glacier. It's up to you, whatever you want. And the data is immutable. So once it's there, it's there. And this is one of the most interesting points is, it is a long-term archive, but it takes about 3 to 5 hours to retrieve it. But that's the same amount of time if you retrieved a kilobyte or a petabyte. It takes 3 to 5 hours regardless of the amount of data. So that's kind of unique. And the price, we just had a price drop recently. It's now 0.7 cents per gigabyte per month for Glacier. So those are the two kind of durable storage pieces. S3 is where people kind of keep their data when they're getting ready to run. Glacier is where they put it after they've computed on it. They're not quite Not quite done with it, but they're not going to access it. But during the runs, one of the things that people need is storage for the cluster in the cloud. And that's what I'm going to talk about, these instance storage, the various options for our compute instances. So an instance is really just a node, if you want to think of it that way. The first option is something we call Elastic Block Store, EBS. It's basically network attached storage. You can think of it as iSCSI if you like. But it has the capability of doing snapshots. You can encrypt the data on EBS if you want. You can control the keys for that also if you want. When you provision it, when you tell Amazon, I want EBS volume that has this capability, you can specify the IOPS. And the way it typically works is the more IOPS, the more you have to pay, so you want to kind of keep an understanding of the IOPS of your application. But we also have the option of using magnetic or SSD-backed volumes, up to 16 terabytes and 20,000 IOPS per volume. And you can combine multiple volumes and create one large back for a file system, for example. So I've done up to a couple of 100 terabytes using EBS volumes. And this is outside the compute instance, so this is separate. Now, inside the instance, in some cases, we have what we call ephemeral storage or local storage. So in the instance, it's like the hard drive inside your laptop. It's a storage facility inside the node. But the reason we use the word ephemeral is once you're done with the instance, that data is erased and taken away. So it's ephemeral, it's not going to last. So you have to manage all backup and restore. But the greatest thing about this is it's free. It comes with the instance. This you have to actually pay for, although it's not very expensive at all. But this one is free. And here's some examples of a couple of instances. We've got an instance that can do 6.4 terabytes in SSDs. We've got some that can do 48 terabytes in local disk. So there's a fair amount of options. Which one you want to use is kind of up to you and up to your situation. So know your application, know your workflow. So with EBS volumes or even ephemeral storage, you can then build your own kind of file system if you want. So it's really easy to use NFS or CIFS. Inside a product, a facility we have called the Marketplace, you can actually use Lustre supported by Intel Cloud Edition of Lustre, ICEL. So it's like renting a product. So you're going to rent Lustre during your run, and then when you're done, you turn it off and you've paid a small amount of money to Intel. Same thing for Gluster and OrangeFS. Avir, has a booth here as well. You can soft NAS if you really want to do ZFS. NetApp is available, and there's a lot more. So you can go into the marketplace and you can look at different file system options and find out what works well for you and find out what the cost is. I just want to give a quick example about Lustre, since this is the HPC show, supercomputing conference, is that some people may think the cloud is not that performant, but I want to show you that it actually is. So Intel they just used standard instances and EBS volumes and created Lustre. It's all orchestrated behind the scenes for you. It has failover capability, but the performance is really pretty good. So for example, they used 8 OSS nodes and 16 clients, and you can see the details here about the benchmark IOR. But they ran on a terabyte file and this is 8 OSS nodes, they got just about 2 terabytes a second writes and about 1.9 gigabytes a second, did I say terabytes? 2 gigabytes a second, I'm sorry, and 1.9 gigabytes a second for reads. But they also showed that it scales with the number of OSSs. So 8 gives you just a little bit under 2 gigabytes a second, 16 gives you just a little bit under 4 gigabytes a second, 3.7. So it scales. So the great thing about Lustre in the cloud is, do you want 8 OSS nodes? Do you want 16? Do you want 32? Do you want 2? It scales. Whereas on-premise Lustre systems, you have a fixed number of OSS nodes, and that's where you're going to stay. I did mention earlier, talk about data movement, but I'm just going to mention some services we have. I'm not going to talk about them too much, and that's a way to get data into the cloud. The first option we have on the left is import-export, And this is the idea of mail your hard drives to us, we load it into S3 for you, and then we mail your hard drives back to you. We also have direct connect. So if you want to work through a local provider, you can, like Equinox for example, you can get directly plugged into Amazon. By the way, Amazon has an I2 link, so if you're on I2, you can get into Amazon very easily. We also have something we call Storage Gateway, and this is the idea that you have an on-premise appliance. The node is yours, the software actually comes from Amazon. Right now you can have up to 200 terabytes on site, and then the rest of it is automatically moved to AWS for you. I'm not going to talk about too much about data pipeline. We found not too many people in HPC use data pipeline. And then there's kind of a product here that I did not have to symbol for. We have a new product we call Snowball. So rather than sending disks to us, what happens if you have 50 terabytes of data? Well, we have an appliance we call Snowball. It's ruggedized and we ship it to you. You put the data on it and then you mail it back to us and we upload it for you. So it's more for one-time kind of data uploads. You're not going to do this continually. But if you have a bunch of existing data and want to move to the cloud, it's a great way to do that. And I always want to finish with my last comments about managing and monitoring your data, because I think this is extremely important. And Amazon has a number of capabilities for managing and monitoring your data. The first one is what we call Amazon CloudWatch, and this allows you to track and collect metrics. There's some standard metrics that we define that you can use automatically, or you can define custom metrics. We collect those and put them in log files, so you can look at them later, process them later, or what I like to do is set the alarms. So if your capacity of your file system reaches 90%, it'll set off an alarm, which means it gets you an email, and you know you have to go do something about it. We also have CloudWatch dashboards. So if you want kind of a graphical view, so you can look at bandwidth, IOPS, and capacity, for example, you can define those metrics and see that within the AWS console. We also have, this is an important one for the security people, AWS CloudTrail. So basically everything in Amazon underneath the covers many times is an API call. With CloudTrail, you can track every single API call. Who did it, what were the arguments, all of that. If anybody's going to interact with your resources in the cloud. And then we deliver these log files to you. So that way you can find out who was doing what, and did they shut down a node, for example, by accident, or did they start up something on purpose, or even by accident. So this is a great way to do auditing of any of your resources. And then S3, which is kind of the center where you want to keep your data for working on it, it also has the capability of logs. So you can turn on logs for it, and it will find out who accessed the data, it will tell you when it was accessed, which object, all kinds of different things. It also tells you which accesses were denied. So then you can look if somebody's trying to get your data illegally. And then if you're going to move your data in and out of Glacier, we also log that as well and present that to you. So you set up the policies, the migration happens automatically from S3 to Glacier, and then we just give you the information in logs. It's all wonderful, so you can process it later at your leisure. So with that, I'm actually going to stop. Any questions? I think we're wrapped. Thank you very much. I appreciate it.